Hello there, it's Mr. Frazier again. So here I am with Form A's test. And again, I'm going to go through Form A. Please remember that you should have already downloaded the copy of the form that you took, and you're going to have to find the matching answers. Okay? So in other words, you're going to have Form A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth through 20. On Form B, C, D, and E, you'll have to find the matching question. Okay? It causes you to do a little bit of work. All right. So we go ahead and we look at Form A, Problem 1. And hopefully you understand that when we look at this, you're supposed to notice that 1, it's discrete, the dots. 2, it's a function. It passes the vertical line test. None of the x's repeat. 3, it has an absolute maximum. So these are the things you're supposed to know before you look at the multiple choice. So now I'm looking for discrete. So as I look through my answers, you should see, well, one of them says discrete. But it says it's a function. Okay, well, we all know that these are functions. But this one says exponential. This is not exponential. We already know it's supposed to be absolute value. So now I look down, absolute value. I don't have, here's one with absolute value. Here's another one with absolute value. Well, it's not linear, so it's not this one. So when I look at it, now I know it's either got to be C or D. It's a function. It's linear absolute value. It is discrete. It's going to be C. All right. Problem number 2. It asks us which one of these is a linear function. So, when x is in the absolute value, it's an absolute value. When x is the exponent, it is exponential. When x is squared, it's quadratic. So, this is my only choice, when the x is the only thing there. Okay? We're not worried about anything else. We're worried about where the x is. So what do most of you make the mistake? You didn't know where the x was. Now you see it, but you don't understand, or you didn't understand, that if the x is squared, it's quadratic. If the x is in the exponent, it's exponential. And when the x is in the absolute value, it's absolute value. Problem 3. Problem 3 says, what is the classification of this function? So here we are. The x is where? The x is in the exponent. This function is exponential. So again, most of you say to yourself, oh, I didn't know where the x was. You have to know where the x is, and that makes the function. Problem 4. Grissom draws different size spheres in a notebook. He knows that there's a relation between the volume of the sphere and the length of the diameter. What is independent in this situation? So, we know that there's a relationship between, and they tell us the two things, the volume of the sphere and the length of its diameter. So we have to re-say it. Does the volume depend on the diameter, or does the diameter depend on the volume? Hopefully you said the volume depends on the diameter. When the diameter gets bigger, the volume gets bigger. When the diameter gets smaller, the volume gets smaller. So you were supposed to say the independent is the length of the diameter. This one was a hard one. Many people missed. Sarah drove to the grocery store. She was at the grocery store for several minutes, then she drove back to her house. The graph shows the relationship. In the graph, what is the dependent? You don't even have to make sense of this problem. You should know that on a graph, the independent is always here and the dependent is always here. So when it asks for the dependent, I know the distance from Sarah's house is the dependent. The units is miles. So the distance from Sarah's house in miles. You should know the dependent and independent is one of these two answers. So if you would have picked Sarah's house or grocery store, you should know you're wrong, because the graph tells you what's dependent and independent. So being able to put those things on the graph, pull them off, put them back on. Number 6, which is a quadratic function. So I'm looking for x squared. So where do you have x squared? Well, hopefully you know it's not here, because that's x to an exponent. This is an x in an absolute value. There is no x in this problem. So I'm only left with 1. Well, it must be b. Why? Because here x is squared. Which graph does not represent a function? So one of these graphs, A, B, C, or D, is not a function. We can use the vertical line test. That's a function. That's a function. That's a function. C is not a function. Why? Because I should have used the vertical line test. Number 8. Which of the following descriptions is not true of an exponential function? So that means several of these are true. One of them is not. Okay? It increases or decreases. That's true. It's a smooth curve. It's true. It can be discrete or continuous. That's true. It has an absolute maximum or minimum. Exponentials do not. Remember, exponentials are either increasing or decreasing. You only have maximum and minimum when you have the top of the hill or the bottom of the valley. So anything that changes directions, yes. It has to increase and decrease. Exponentials only increase or decrease. They can't do both. Number 9. Which best describes this function? Well, let's ask. Is it increasing, decreasing, both, or constant? Hopefully, no. We were supposed to look at the number in front of x to tell whether it's increasing, decreasing, constant, or both. Well, the only time we have both, increasing and decreasing, is absolute value, which there is none, or x squared, which there is none. So it can't be increasing or decreasing. The only time we have constant is this over here, there's an x missing. So if this had said f of x equals 2/3 minus 27 with no x, then it's constant. But because we have an x, it can't be constant. So it's either increasing or decreasing. Well, when we look in front of the x, that's positive. Positive 2/3, which means it's increasing. It would be negative 2/3, then it would be decreasing. Number 10. I start to pick up pace now. Kelly has different sized soup cans. They're in the shape of a cylinder. She knows there's a relationship, they're telling you, between surface area and the length of its radius. So does the area depend on the radius, or does the radius depend on the area? Hopefully you know this is just like volume. The radius does not depend on the area. The area, how big it is, depends on the radius. Okay? The area depends on the radius. The radius does not depend on the area. And I tell kids like this: the amount that the umbrella covers depends on how big the umbrella is. The radius is the length of the umbrella. So if the radius is bigger, then the umbrella carries more. Okay, number 11 should have been a gimme. It says, which equation does not represent a function? So hopefully we know that functions are f of x or problems with a y. If it doesn't have a y or f of x is called the function of x. If it's missing the function of x, it means it's missing the function. Which one of those would be missing the function? Yes. There's only one that does not have y. If it doesn't have y, it doesn't have a function of x. When the f of x is missing, it's not a function. Problem 12. What do I know about this function? Well, hopefully you know this is an absolute value because the x is in the absolute value. There's also a negative sign outside of it, which tells me the absolute value goes down. The whole thing faces down. It increases, then decreases, which means this is an absolute what? Correct. Maximum. So, can it have a maximum and a minimum? Nope. We already know that that's not an absolute minimum. And it has one or the other. So it has an absolute maximum. Okay, 13. Identification again. Which one is exponential? I'm looking for an x in the exponent. Well, this doesn't even have an exponent. This has an exponent of 2. That's not going to work. This doesn't have an exponent. This is the only one with an exponent of x. Problem 14. What characteristics describe this? So hopefully you know this is a function. It is continuous. It is exponential. And it is decreasing. From left to right, it's going down. So, it's a function. It's exponential. So far, so good. Up, discrete. No, this is continuous. So I crossed that one out. That can't be the right answer. So I'm looking through these things. Well, it's continuous, it's functional, and it's decreasing. Uh-oh. 14. B looks like the right answer so far. It's linear. It's not linear. Beep. It's linear. It's not linear. Beep. So it had to be either A or B, and we figured out that it must be B. Problem 15. Which one describes the behavior of the function? Meaning, what direction is it going? So when I read this, this says f of x equals negative 3/5. Up, something's missing. Where is my x? It's not there. This is a constant. When you're missing the x, it's a constant. When it's not a function, it's missing f of x or y. Next, 16. Is this a function? Of course it is. Excuse me. And we look at it again. F of x, and it seems to be raised to the second power. That means it's got to be quadratic. Quadratic means we go like this. All right, so we know it's quadratic. Does it have an absolute maximum or minimum? Well, in this case, it has a minimum. Because the sign in front of x is not negative. So it's a minimum. You can't have a maximum and a minimum. You can have something not have a maximum or a minimum, like a line, but it's either absolute maximum or absolute minimum. In this case, correct. Most of the reasons why you won't be able to tell me what about this function is because you're not remembering your function families. I didn't remember my function families. Or I forgot anything squared is quadratic. 17. Which is a constant function? So that means what is it missing? Constants are called constants because they're missing the x. So here, this would have been quadratic. We know that's not going to work. This would have been linear. That's not going to work. This would be absolute value. That's not going to work. So I know what these three are called. That's got to be the constant. Number 18. What is the classification of the function? Hopefully you know it's to the x squared. There's a power of 2. You can also eliminate. There is no absolute value signs. Can't be that. There is an exponential. There is an exponent. So it could be exponential. It could be quadratic. But it's definitely not linear. And we know that an x has to be the exponent for it to be exponential. So it's C. But it's knowing that when you have x squared, it's quadratic. Number 19. It says Carlos walked from his house and he was at a school. He was on his way home. You should know from the graph, the bottom is independent. The side is dependent. So you should be able to tell me which one of these is which. And in this case, they want to know what is the independent quantity, and it is time, measured in hours. If I want to know what the dependent quantity was, I'd go over here because the dependent's always here, and the independent's always here. So you didn't necessarily even have to know which one was dependent on each other. They gave you the answer. The independent's always on the bottom, the dependent's always on the side. Last but not least, problem 20. Which graph represents a function? Well, this one fails the vertical line test because it is a vertical line. So that's not true. Let's look at the next one. The next graph. We're looking for something that is a function. Well, this one fails the vertical line test. No matter where I draw the line, it's going to touch twice. Well, this one's not a function. It fails the vertical line test. Now remember, when you have double x's, that's also the reason why it isn't a function. But because it's on a graph, we don't have to write down the points. All we have to do is use the vertical line test. If you wrote down these 2 points, you would know that that one is -1, -1, or excuse me, -1, 1. And then down here is -1, -1. And you would realize, wait a minute, I have the same x value twice. This is not a function. So last but not least would have to be D. D is the function. It's a constant. That means it would be f of x equals a number. Doesn't matter what number it is. In this case, it's 2. Okay, because the line's on 2. But it is a horizontal line. It is flat. All right. There's the test review. Hopefully you've listened and wrote out the original question. If you're not sure about it, I will tell you that they will be posted online by the end of today. Have a great day. I look forward to you having the test corrections done as well as the skill practice so that you can retake this test. I will probably do another on-live Illuminate review for this test. Actually, I would probably just have you listen or watch the one that's already recorded. Thank you very much. Have a great day.